Okay, so let's try to go towards Lisp now. Okay, and we have half an hour left. So let's try to change things a bit, or a lot. Okay, so a lot of you guys said we want to know functional languages. Okay, what's a functional language? In a functional language, everything is an expression. There is no such thing as a piece of code that independent code, there's no statement. Okay, so we have to somehow do all the things we want to do without statements, or at least with everything returning a value. Okay, there's only one kind of operator, prefix, no infix, and we'll kind of see what that means if that's not making sense. I said that bash, I was comparing bash and C. Bash comes with an interpreter called the shell, okay, or the bash shell, and we'd like an interactive interpreter because this was designed for AI. It might be the language that defined AI. Anybody have an idea historically when Lisp might have been invented, when C might have been invented? And I'm bad with dates, so this is not something I'll ever ask you in an exam. But do you guys have any idea which decade it was invented in? C, or Lisp, for instance, might have been invented in? Or at least C, what decade might that have been invented in? Think as old as you dare to. C came with an operating system called Unix. Anybody know when Unix was invented? When is really old for you guys? Nobody want to guess also? Sorry? Or did you Google? Yeah, so I didn't know it was 69. I know it was in the 60s, the project, late 60s, that the project was at Bell Labs. Okay? And it was late 60s, 70s, so it was late 60s. And the Lisp, do you think came before? Yeah, 59, apparently. A guy called McCarthy invented it. So it's not as if Lisp came after C. Okay? But I took C as the starting point, and I'm going and doing a little diff from C to get to Lisp. And I'm going to use C syntax to show the diff rather than Lisp syntax, just so that you don't get confused by syntax and you focus on the concepts. Okay? So this is meant to, this was meant for AI. AI, in AI you really don't know what you're doing. And so you just want to be changing things often. So there was an interpreter there. We don't want to have to compile, edit, run. That takes too long. When you're doing an interpretive language, you don't want to spend time writing down type names. Okay? And if you're not going to type something, and if you want type checking, then you're going to get dynamic typing. Okay? You're not going to get type errors at writing time, only at execution time. And it had something called parameterized block expressions, which we look at, and it really gets its name from the Lisp processing it had, which we won't look at in this example. Okay, so let's go and see what these things mean. So in C and in Pascal, which I'm mentioning, and in Java, we can divide constructs into statements and expressions. Okay, and what would you say is the difference between a statement and an expression based on what you know already? Which set of values are expressions here, and which set of values are statements here? Yeah. And the bottom are expressions. So do you want to give a definition of a statement and an expression then? So you see the pattern, and you're kind of getting there that, look, the assignment statement is a statement. Yeah. Expressions have a value. Okay. An if statement doesn't have a value. 5 plus 3 has a value. Okay. And if you think about learning programming, there are two analogies we use. One is the recipe analogy. Hey, imagine a cookbook, all the steps there, that's a recipe. That's essentially what programs do. That's a very statement-oriented thing. do this, do this, do this, do this. That's called imperative programming. The other analogy is functions. Hey, you've already studied mathematical functions. All we do in programming language is make them executable, and we provide that abstraction there. And so statements perform step, imperative, do this, do this. It's like a void procedure, okay, a void method, which is a procedure. And they return values, and when you don't put void against a method name, you get a function, okay? So void versus non-void is essentially the difference between the two, okay? So Lisp says, we are very mathematical, originally computer science came from mathematicians, okay? So let's go and make a language that is very mathematical, which means we're just doing a lot of expressions and combining expressions together and putting expressions into functions, giving them names, and so that's the goal. That was one of the goals, okay? Of all functional languages, that's the goal. It's kind of hard to do everything that way, but you can do many things that way, okay? So if you're trying to get rid of all statements, you do need to assign values sometimes, okay? In fact, 40% of programs when I was studying a long time ago were assignment statements, okay? Functional languages try not to have assignment statements, but in practice they kind of need to. So how do I make this statement into a function? In fact, if you know enough C, the answer exists in C. If this was to return a value, what value would you return? So total score is being assigned a value, and I want to make this program fragment return a value. What would that be? The value that I assigned, right? Now, can you say something like that in C? While n equals something, and that n equal be an expression. Have you guys seen such code in C? You have? So n minus minus and n minus minus n, what's the difference? How many of you, yeah?
Prefix happens before evaluation and post.
So in one case, in both cases, it's going to return a value. The question is the value returned before the increment or after the increment? So that means assignment statements in C return values. Okay? Very confusing. But they are like Lisp. Okay, so this concept that I said, exists in Lisp as a speciality, actually exists in C too. Okay? What if I were to make this into a, we saw that in Lisp there's a format call that you can make, which is like the printf. So what would be the value returned by a printf? What should be? Just you have to put on your language designer hat. I'm printing hello world, and I'm assigning the print call to a variable. What should the variable be assigned? Hello world. So when I've taught 110, even in 401 sometimes, students are very confused between printing a value and returning a value. I go and tell them, write a function that returns the factorial, they'll print out the factorial. Okay? So there is an intuitive, this seems unintuitive at this point because we've learned a lot. But when we haven't learned a lot, that is actually kind of intuitive. Okay? So that's going to return the value we print out. It's going to print out a string. Okay? And that's kind of confusing because when we call a function, if we call a function once and we call the function a second time with the same parameters, you expect the same value returned, right? If I say add 2 plus 2 3 times, it should always return 4. But when you go and allow this to happen, there are side effects. There are things, side effect is anything that's unexpected. So you're returning the value, that's supposed to be the main event, and you've done an increment, you've gone and printed it on the console. So it's something that people frown on. And that's why even though functional languages kind of have this, they say, please don't use it if you can. Okay, there's a language called FP that says, we'll not allow any bad things, any side effects, and we'll somehow solve the problem. And, 5 decades after it was invented, it's still trying to solve the problem. Okay, it's a very hard problem to solve. Okay, one of my office mates actually joined the group, so I kind of know what's happening there. Okay, how about this? How do I go and replace an if statement with an if expression? And actually, I've shown you code that does that. Yeah. The ternary operator. Okay, exactly what you're saying. Okay, so I use this actually. I put the condition, question mark. Now I have to have a then part and an else part. I can't just have a then part because I need a value in both cases. I could have just an if then without an else in a statement. With an expression, I must have a then part and an else part. And whatever, as long as everything is a function, whatever goes in the then part will also return a value. What will go in the else part will also be a value, so the if will also return a value. Okay? So basically in Lisp, you work with this ternary if all the time. There is no if statement. There's a different syntax, but that's how you operate. Okay? Questions? How about a while? I mean, with the while you're going in, doing these statements, and what would be there's many probably answers to this, but what's a method scheme what's a method what's something that can replace an iterative loop? So what kind of function call would that be? A recursive function call. So a lot of you guys said we want to learn recursion. A lot of you guys said we want to learn functional programming. And these two things were the same thing. Because you cannot do something, you cannot do most interesting things without recursion in this. We won't see recursion in our example, but we see that recursion is very important to functional languages. Okay, so you can go and do something like this, and you don't even have to use loops. You can't use loops. None of these languages have loops. Okay? Okay. The class is quietened down a little bit. Please ask questions. Okay? If anything is clear, not clear. But we'll see this point reinforced many times. Okay? Okay. Now things get a little easier, hopefully. So, in both cases, I'm calling a function, right? In one case, I'm calling the plus function. In the other case, I'm calling the pass function. What's the difference in syntax here? What are some technical terms you can use for the two syntax? In one case, the parameters are 60 and 70, and the operation is plus. In the other case, the parameters are 60 and 70 again, and the operation is pass. And the syntax difference is? Yeah. Infix versus prefix. Okay. So we can always use prefix. So this is multiple invocation syntax. And here we will use just one. Okay. And the prefix is more general. Infix means binary. Prefix means any number of arguments. So we'll use that. So we're taking things out of C in Lisp, which is kind of good, right? If you're going to do a Lisp interpreter, it better be a small language. Okay? So parsing ease with infix, and those of you who've done compilers like Robert has, it's easier to parse prefix because you have the operation before the parameter, so you know what kind of tree node to build. With infix, you have to go further down and say, oh, this is what I want to do. So it's harder to parse. Okay. So in Lisp, in C, we say double total score equals 0. In Lisp, we don't give type names. We just say total score equals 0. And you guys have used languages that don't require type declarations? Python? Okay. And if things go right, these are equivalent. But what happens when things go wrong? What happens in Python, by the way? I ask you because I don't quite know the answer. If I go and say, if I go and use total score less than 0 and have declared total score to be a string, what will happen in Python? You get the error at runtime?
Yeah.
Okay, so you get, in Lisp, you get an error at, so this is, you'll get an error, in C, you'll get the error at compile time. Okay? And in Lisp, you will get an error. It might be a strange error that doesn't give you much information, as we will see when we see Lisp exactly, and you'll get a later error. Because that's why C is, that's why even though C I said is a dangerous language to program in, Lisp is even more dangerous in this respect. Okay, so we have dynamic typing. So now we are building a taxonomy also. You know, languages that have functional versus imperative, compile time checking versus runtime checking or dynamic checking. We're building this taxonomy, which we'll formalize even more later, but we are seeing some relationships. Okay, static typing, dynamic typing. Okay. Now, wouldn't it be nice, at least for this problem, if we didn't need to do scanfs and printfs? If somehow the system automatically did that for us. That seems like magic. But look at this piece of code, not general code. What are the scanfs and the printfs together trying to do? I mean, they're printing out the value, but in terms of language, what are they trying to do? Yeah. They're trying to communicate with the user, and that's what I/O does. But in this example, what are we really doing in terms of the code we have implemented? We're taking the two parameters, two variables, and passing them as, using them how? Arguments to a function. And then what are we doing? What is the printf doing? Printing out the return value. Now, a programming language knows about functions. It knows about pass. Wouldn't it be nice if it just allowed you to call the functions interactively? If I just said pass 60, 70 and said, hey, the pass the programmer has defined, please go call it with 60 and 70. And the interpreter, the runtime, just goes and calls the pass function. Because there's a direct mapping between the function call and what we're doing. I'm saying in this example. I'm not saying in general. Okay? That's what we'll see ML, we'll see Prolog, we'll see Lisp, they all have this spirit. That's what Bash does also. Okay? So we can get rid of I/O completely. Or at least, sorry, we can get rid of I/O partly at least. And the way Lisp is used, we don't tend to do other kinds of I/O. Okay? So edit, compile, load, run cycle with manual runtime input output. Here we have runtime, edit, interpret. You edit the thing, you enter the stuff, interpret, and there's a UI for calling the function. So you're writing less code. The whole idea is to write less code interactively, and that's what we're seeing in these languages. Okay? Questions? Okay, this was kind of simple. Let's look at something that's probably the most complicated thing, or maybe not. So in C and in Java, we have blocks of code within curly braces, And we have functions or methods that are associated with blocks of code. Okay? A block of code can exist inside a function or a method, or it can exist independently as some. It can be the body of the function, or it can be something inside the body. Okay? And there's a uniformity. I can declare variables in both. They're both scopes. Okay? So I have got an int factorial declared in this block of code, which is somewhere embedded inside the body of the function. And I've got int factorial declared in the block of code with the function, associated with the function. Okay? So both functions or methods and blocks of code are very similar to each other. The difference is that a method call can be parameterized. And it has whereas a piece of, any old block of code is not parameterized. Only the block of code that happens to be the body of the function, in which case the function is parameterized, not the block of code. Right? So this block of code on the left cannot take any parameters. Whereas the function takes a parameter int n. Won't it be nice if we could also, I don't know if it's nice or not, but to increase uniformity, we could go and have arbitrary blocks of code take arguments. Okay? So what could we do? We could have this is not in any language, but it's similar to something that some of you might have seen. This piece of code is associated with the parameter, and it uses that parameter. Okay, so the block of code has got int n in it, associated with it. So now it's becoming more like a function. Okay, anybody seen this in the language you've used? Yeah. In Clojure, in which language? Sorry? Java 8. Right? It's called Clojure, or what else is it called? Yeah. Sorry? Anonymous function, yeah, you can call that something else they use for Java, because that comes from Lisp. Huh? Sorry? Were you going to say something? Yeah. Lambda expression. See, I read your lips. So, and the lambda expression terms comes from Lisp. Okay? So how do you use, what do you do with this? How to use parameters blocks? You can go, there are two uses. You can just go and pass it a parameter directly. Okay? Or you can go and associate that with a function. And a function is just a name for a parameterized block. Okay? So that is another thing, that quirk you'll see in Lisp. And Lisp was invented in 1959, and Java 8 came a few years ago. So it's back to the future. Okay? And that's why it's good to sort of look at this history. And there are still concepts there that are relevant, that just don't happen to be in production languages. Okay? So Java lambda expression. And it's not really an expression in Java. The lambda part, the block cannot return a value. But they just use the word lambda expression because in Lisp they use the word lambda expression. Okay? Okay. So all this talk, and we haven't seen Lisp so far. So this is the syntax. It's all prefix notation. I go and say setq. Okay, there's no assignment operator. There's no infix assignment operator. There's a name. There's a function call called setq, and I'm just defining my. So what I'm seeing, what you're seeing is the left box and the right box. I can enter things interactively, and then say tell Lisp go and input this file, and then I can so I can put it in a file, ask Lisp to process the file, and then I can provide further input interactively, which is what I did. Okay, I can never get any syntax right. I can especially not get Lisp syntax right. So I don't want to go and have to type all this code and hope that it compiles right. So I just take an editor in Eclipse, which will go and do all the checking for me, and I go and tell the environment run the file. And what it does when it runs this file is saying, oh, I evaluated setq pass cut off 60 as if you've entered it interactively, and its answer is 60. Okay, that's what I said. Assignment statement's value is what you assign. So, oh, I went and defined this function, and its value is regular pass. Okay, because it doesn't have a value, so the value is the name of the method. Okay, and I've done this without lambda expressions, but you can do this with lambda expressions also. Okay, in fact, I didn't realize I did not do it with the lambda expression, so all that talk, was not relevant to what the example is. And what are we doing here? That cond thing is just your ternary operator. It's saying if total pass is greater than or equal to 1 cutoff, then what does the T stand for? What could it stand for? Return true. Otherwise, so the cond happens to be an if statement. It has pairs of list of pairs. The left element in each pair is a Boolean expression, and if that expression returns true, then we return as the value of the if the right expression. Okay, so this is saying check if total is greater than or equal to pass count. If that's true, return true. Otherwise, check the next pair. The next pair is saying that the left hand side is T. True is always true. So whatever happens next, so that will always be true. So that means return nil or false otherwise. Okay. So it's just your ternary operator, which can take a bunch of Boolean expression, a bunch of pairs rather than just one pair. Ternary operator just takes one pair. This takes multiple pairs. Okay. You're confused. I'm looking at, yeah. So tell me what. So there are two T's. One T is on the right hand side, one T is on the left hand side, right? So we've got a list of pairs, right? Cond is followed by a list of pairs. Each pair is on a separate line, right? One pair is greater than or equal to total pass count and T. The other Lisp stands also, by the way, for lots of irritating silly parentheses. So you see a lot of parentheses here. Okay? So let me see if I can point here. So we have cond, we have one pair here, the other pair here, right? This pair has got two elements. This is a compound element. This is one expression, this is another expression. This is one expression, this is another expression. This happens to be the true expression. This happens to be the false expression. Okay? So this says this expression will be true if total pass cutoff is greater than or equal to, total is greater than equal to pass cutoff. Okay? And remember, we're using the prefix operation. Just as we're using, we're using prefix operation here. And if that is true, we return true. Okay? And then we are saying, if true is true, so you come here only if this expression is false. If you come here, evaluate this expression. That always happens to be true. Okay? So return nil or false. And we associate this body with the function named regular pass. Right? So the ternary if is kind of confusing. Yeah. No, you don't have to have that. If you have nothing, it will return false. But I read up and I agree with it. It's good form to go and put that in. Okay? Because you're just saying, it's uniform. It's saying, it's like a switch statement. This clause, this value, then other. Otherwise. And a switch statement, it's good form to have an otherwise. Okay? We have, yeah. Sorry, how would you implement it using a? So we won't, infix, you take the compiler course. Okay, how to go and write a grammar with infix. But with prefix, it's easy. We write a nice recursive descent parser to do that. We'll just go and look at the first symbol. Based on the first symbol, we'll go and do something else. So Lisp is very hard to use, but it's easier to do, which is kind of good music to your ears. Okay. I have 30 more seconds. Let me quickly, we'll go through this both again, both slides again. But now you see how it's going. I go and define some more constants. I go and do a high final pass. Again, I've got a bunch of cond expressions, lots of embedded parentheses. But now my left-hand side of the first cond element is a compound expression, and you're seeing how I'm doing and also. Again, we're using infix, and we're just using a compound expression. Okay? And we're saying if final is greater than or equal to high final threshold, and total is greater than or equal to high final cutoff, then return true, otherwise return false. Okay? And my pass is just doing an OR of regular pass and high final pass. If that's true, return true, otherwise return false. Okay? We'll do this again next time. So let's review what we were doing. We took this problem, which is a fairly simple problem, not quite hello world, but still pretty simple, where we decided that we were going to have two criteria for deciding whether somebody passes or not. One is the regular criteria. If they are above 60 or equal to 60, they pass. And then there's a fudge thing that says, oh, you know, if they didn't quite pass, but they did well in the final compared to they did really well in the final, and they did get a certain amount in the total. And so we'll pass them then too. Okay, there can be so many criteria. The fudge criteria can be many. And we just took this problem and we looked at different ways of doing it. We started with C, and there are many ways to use C. And the way we used it first was it's a small program. So one of the students said, what's wrong with just putting it all in one main method? Okay. And we saw that an issue there was duplication of code. And the question then was, what if the code is just a line or two of duplication? Okay. What's a big deal? And it's not a big deal if you're copying the code and pasting it. It may be faster to do so than defining a separate function. But we saw that the problem can lead to duplication of code with inconsistent changes made to it later. Okay, so that's an important point. Okay, that we don't want duplication for consistency. Okay, so we decided to be good, and I divided the code into a bunch of functions, and I presented the functions into two groups. One is a logic. Okay, that's, you know, we define a regular pass function. We define some named constants it refers to. And then we define a high final pass and define some named constants it refers to, and then we define a general pass which looks at these two alternatives and says if any of these alternatives is true, it's a pass. Okay, so given what you guys have programmed in previous courses, this was pretty simple. Okay, and then we did a bunch of other the other functions. Well, basically, if they're not logic, what are they doing? Well, they're doing input and output, and they got the main method too. Okay, so we divided this slide into this slide has those two functions. Okay, and then we saw some things in C that, as Java programmers, we might be surprised. Okay, we saw the ampersand. We can put an ampersand before a variable to basically reference it. Referencing it means you go and find its address. So when you reference it, the expression returns the address rather than the actual value of the variable. Okay? And then we saw a star function, which is dereferencing, which says take an address and tell me what the value is. And we dereferenced it during parameter declaration, and we said, look, input double takes a variable that when dereferenced is a character. So we know that we are passing a reference to this reference parameter, and the reference parameters are all addresses, so they're not typed. So we are telling the program, we are telling the reader, and we're telling the compiler that I want something here that, when dereferenced, is a character. Okay? So there's the notion of getting addresses and dereferencing them, and you can do that with arbitrary addresses, and that's great if you're an operating system programmer. But if you are a hacker, it's also very. If you're a security breaker, it's also very great. It's also great because you can go and do funny things in the program that were not meant to be done. And so, if you're somebody who's being hacked by a security hacker, that's not good news. Okay. So we saw there's pros and cons. And then we saw that functions can be used not only for avoiding code duplication, but just like named constants can go and give a name to a piece of code that you have there that may not be clear otherwise. Okay, so if I just went and said set vbuff something something something, you don't know what it's doing, but I put that in a function called enable output flush, and that hopefully gives you a little bit more information about what's going on. Okay, and these descriptive names can take the place of comments. Okay, comments get outdated very quickly. Programmers are generally lazy about commenting. So this is a good way to have your cake and eat it too, that you have descriptive things and you didn't have to go into an extra step of commenting. Okay. This enable output flush, based on my memory from a long time ago, when I used to program this all in Unix, I never remember having done this. So I said that this is probably a Windows quirk, and that brings out another point that, unlike Java, which is supposed to be portable and working for any operating system, that means it abstracts away things, which means you can't get at OS-specific things. This one does not hide the OS, which is fine if you're an OS programmer. You want to be influencing what the OS does. Okay. So that was C, and we wanted a path to Lisp and motivate why we should study Lisp. Okay. And we saw that, look, so we were trying to figure out what is it about Lisp that's different from C, and Lisp is an example of something bigger, which is a functional language. So we wanted to understand also what a functional language is compared to whatever we've been studying before. So people like me who grew up on languages like C used to call C conventional languages, and all my papers refer to these things as conventional languages, but you guys grew up much after object-oriented languages were created, so the word conventional doesn't really apply to you. So we'll call them procedure-oriented languages. And so there's functional languages, and in functional languages, you're basically taking off things that are in these procedure-oriented languages. Okay, I might call them conventional just from habit. So in these C-like languages, we have things that are statements. We have constructs that are statements, and we have constructs that are expressions. Statements are imperative. They say, do this. And expressions are functional in the sense that they return a value. And in functional languages, we don't have statements, or if we have statements, they return values too. So everything returns a value. Okay, so that's kind of so that may sound counterintuitive, but that in fact, even in languages like C, that exists. Assignment statements are actually expressions in C that return the value assigned, and that's why you have n minus minus n minus minus n. And we don't see this in C, but we could imagine that printf returns the value that was printed. Okay. If statements get replaced by a ternary, by a ternary, the equivalent of an if statement the expression equivalent of an if statement in a language like C or Java is the ternary conditional operation, which takes, and we'll talk more about this in the next slide. That's the one that sort of was a little confusing last time, which basically looks at a Boolean expression and returns, and based on the value of the Boolean expression, returns one of two alternative expressions, which may or may not be Booleans. Okay. How many of you have used a ternary operation? Okay, a few of you. Okay, so for those who haven't, its syntax is a bit confusing. Even for those who have used it, it may be confusing to you too, but it's powerful. Okay. So and then what about while loops? while loops can get replaced easily by recursive functions. Okay? So functional programming typically involves recursion, as some of you pointed out when we were talking about the motivation of studying programming languages. So that's one big deal, and that's common to all functional languages. And there are then some Lisp quirks. Okay, let's talk about this ternary operation, because when I went to the Lisp equivalent, I think I lost a lot of you. Okay, so let's do this more gradually. So let's look at a regular if without an else. Okay, so the syntax is if, Boolean expression, then statement. Okay, so we don't have an else part here. We are saying that if the condition is true, we do the statement, but if it's false, we don't say what happens. If you're going to replace this with an expression, we have to give the value returned by this conditional operation. So we need a value also when the Boolean expression is false. Okay, we just can't have only the then part. We need an else part too. So there is no equivalent in functional languages for this. Okay. When we have an if with a then part and an else part, then we see the symmetry here. We just see different syntax because we can't use the if keyword twice, one for the statement and one for the expression. But we see the structure, the parse tree that you'll build is very similar. Okay, it takes a Boolean expression, so that's a top level node, and then it has two alternatives: the if alternative and the else alternative. And in one case, in the statement case, the if alternative is a statement that you execute, and so is the else alternative. And in the case of the functional case, the two alternatives are expressions. Both should be of the same type, and either the then expression is returned or the else expression is returned. Okay, so before the colon, you have to have a Boolean expression, but after the question mark and after the very first thing there should be a Boolean expression. After the question mark and after the colon, the two expressions can be of any type, but they should be of the same type. Okay, the type to which you are assigning the variable, the type of the variable to which you are assigning this value. Okay, so those of you who haven't used the ternary operation, any questions? Feel free, because Lisp is sort of extending this idea. Okay, if it's still confusing, just look up ternary operation, and there'll be lots of data, lots of information in Google. Okay. So that's an if with an else. What about an if with an else if and another else if and another else if? It's a bunch of nested ifs. Okay. So what's the equivalent of that in C or in Java or C? None. Okay. And that's where we go to a Lisp-like structure. So let's try to understand this. What is this saying? This is saying that, look, we have a list of, if the first Boolean expression is true, then we execute the corresponding statement and we finish. Okay? If it's not true, then we go to the next one and we check its value, and we keep doing this till we get to an expression that's true, and we execute that statement. So in general, we have an ordered list of Boolean expression and statement pairs. Right? And we execute statement I if the Boolean expression I is true, and for all j less than I, Boolean expression j is false. Right? So we execute the very first statement for which the Boolean expression is true. That's the formal definition, but you guys kind of know this intuitively. Okay? And if none of the Boolean expressions are is true, well, we might do nothing, okay, or we might do the else part, and we can write else as if true. Okay, we know that true is always true, so we can just say else if true, do this. That's more verbose, so we just have an else keyword, else without an if in that case. Okay, so if all expressions are false, if all expressions associated with the ifs are false, then we execute the expression with the else. Okay. Once you understand this, the Lisp equivalent is very it should be simpler to understand. So we're going to take now again a list of pairs, Okay, and now rather than statement, we have expressions. Okay, and we're going to do the same thing, evaluate the first expression. If it's false, we go on, and we keep doing this till we get an expression that's true. I guess my tick mark somehow got out of order. And so this is ordered list of Boolean expression pairs, and expression I is returned if Boolean expression I happens to be true, and if all previous Boolean expressions were false. Okay. Questions? Okay. And then if none of them is true, then you can say, look, true, just the same thing, that if and that will always be true. So you have something that happens if nothing, none of the other ones are true. None of the specific ones are true. Okay? Okay, so then the other parts are hopefully simpler but awkward to use. So and this is a Lisp quirk. This is not at all something that you'll find in all languages. And why we're looking at this quirk? Because it makes our life as an implementer easy. Okay, as a programmer, not so. And so when you do a plus, you expect that to be an infix operation. But if you're using programmer-defined functions, those are prefix. Okay, so what we will do is we'll try to make everything prefix. Okay, that's what Lisp does. And that's not so intuitive because you say plus 60, 70 rather than 60 plus 70. And to further compound the problem, Lisp goes and changes the syntax to something like this. Okay, and this is where the operation name and the parameters happen to be all part of one list. Okay, anything within parentheses is list. Lisp stands for list processing, so you see the emphasis on lists. Okay. So this is just syntactic confusion. Semantically, we know what we're doing. Okay. Questions? Okay, so what else can we do that's different? Well, in both C and in Java, we tend to type identifiers, variables. Okay. And in Lisp, we don't do so. Okay, so rather than saying double total score equals 0, we say something like, we just don't, we just say total score equals 0. Okay, so that seems good because, who wants to type extra? Well, you guys, you are touch typist. I'm not a touch typist, and yet I love typing. I love typing and typing, both kinds of typing. Yeah. So why do we want to type here? Well, if you do something wrong, if your mind wanders like mine does, you make a silly mistake and you go and say within quotes 0, that hurts you at compile time when the compiler screams at you and you say, uh-oh, let's correct that. When you don't type things and the error might come at runtime, as in Lisp, that means, and it may come silently. It may just say, Lisp might say, oh, that's fine. You know what you're doing. We'll just treat that as an integer. And so I don't know whether you guys still get it with the new programming environments, but what I learned most from Lisp when I programmed Lisp was core dump. It just goes and says, hey, I failed. Something bad happened. Here's all of memory. Go look at memory to figure out what went wrong. Okay. So you ideally don't want to do that. So we have static typing and dynamic typing. In both cases, something bad happened, and the system could figure out that something bad happened. That's what happens in dynamic typing. And you can get a runtime error, or you can get a compile time error. Okay. So if you're the planning type, control type, you want static typing. If you're the if you're a very alert person and you're willing to deal with, plans, things going wrong and adapting, maybe dynamic typing may be fine. So dynamic versus static typing is a big issue in programming languages, and Lisp goes the dynamic typing route. Okay. Questions? Yeah. When would dynamic typing be useful? It's useful so if you go to startups, okay, they want to build code in a hurry. so that they can be bought by the Googles and Microsofts of this world. Okay? So they tend to use Python because they can get something going. And once they get bought, then the Microsoft of this world go and change that to typeware things, and the same guys are made to do that, by the way. Okay, that's, you have to spend 5 years in the company that bought you before you can leave and get your values. So if you want something quick, you tend to do that. Okay, I personally would just use static typing all the time, but from what, Java is a language that's used a lot, and C# is used a lot, but so is Python. And from what I understand, Python tends to be used in startups a lot. Okay. And there are my fellow instructors in my department who just want Python because they don't like the extra typing. Okay. And when you have typing, you have to understand more. So when you're static typing, you have to understand all the static typing rules. So if you want to really learn a language quickly, a dynamically typed language is quicker to learn. Okay. The rules are in general hard to, I mean, that's another thing you have to learn. Okay. And then we saw that, there's some painful things like handling input and displaying output. Okay, I don't think in any course you've done, you got points for learning some concepts associated with this. Just scanf, printf, whatever, and so they're not conceptually deep, yet you have to do them because we want to build interactive programs, and we want to go and try out different values for the functions we have defined. And you can't eliminate all I/O, but certain kinds of I/O you could eliminate. And if you notice in this I/O, what am I doing? I've got a printf, that's the output. I've got scanf, that is input. And what am I really doing? I'm calling the pass function based on what the user has typed. So I first go and have some scanfs that go and read the values that will be parameters for the pass function. And then I have a printf that goes and takes the output of the pass function and displays it. The programming language knows there's a function called pass. It knows what type of values that pass has. Okay? And it has, and so it can actually take what you've entered and convert that into values that are used by the pass function. And it can take the output of the function and display it. It can do that for you, and that's what functional languages tend to do. So you just say pass 60, 70, and it just passes. In a dynamically typed language, it'll just convert it'll convert the primitive values into what the literals stand for conventionally. Okay, so 60 is an int, so it knows it's got to be converted into an int. 70 is an int. You didn't say 70.0, so 70.0 would be a double, and we don't have to write this code. Okay, so interpreter-based language and interactive programming environment. So what we are getting with Lisp is also an environment that goes and does this I/O for us. That is, it has this interpreter with it. Okay? And the word programming environment got invented in the context of Lisp. It got used later too, but there was Lisp and then there was interlisp. That was Lisp with an interpreter, I think. Okay? And interlisp finally got done in a company called Xerox. It still exists, right? It just doesn't do much of computer science any longer. But a lot of good computer science has come from Xerox. Okay? A lot of good computer science has come from many places, but the two companies that can lay claim to a lot of good computer science are Xerox and maybe one other company that you guys might have heard of. Yep. So you need to be a monopoly to do good research. Okay? And Xerox used to be more or less a monopoly. They were really, they're doing Xerox printers, but they had so much money that they could have these pampered computer scientists doing fun stuff. And there used to be a monopoly that got broken up a lot. Sorry? Bell Labs. Okay. So, in fact, and then it became Microsoft. So there was a guy called Chris Fraser at Bell Labs who I knew, and I saw him at Microsoft, and I said, "Hey, Chris, how, and he said, look, You've also come to Microsoft, and he said, look, Bell Labs is no longer a monopoly, and you have to be at a monopoly, so I'm at Microsoft. So, so anyway, into Lisp, so then the idea of programming environment came around, and then programming environments got built for another language called Smalltalk, and so so this is nice. Okay, we then saw probably the most complicated concept, which is like a new concept, but not entirely new. We know that when we define functions or procedures, we can define parameters. Okay, so on top I've got a function called factorial, and it takes a parameter in n as a parameter. Okay? But and within it there's a block of code. You can have blocks of code that are not bodies of functions. You can have blocks of code that are inside the bodies of functions. Okay? In fact, you can have in Java a block of code that is outside any function. Okay? That's a static declaration. So let's try to make things more uniform. The more things are uniform, the less there is to understand. Okay, so things are fairly uniform in blocks of so far. You can declare variables in blocks of code. You can declare variables in functions. But one thing you can't do with blocks of code is define parameters for them. Okay? And functions can return values, but an ordinary block of code does not return a value. Okay? So we try to combine them both, and this is actually done in a convention in a non-functional language. And I've used this time the Java syntax. So here I have at the bottom left, I have a block of code that computes a factorial that can be nested within other blocks of code, and which can then be function bodies. And it takes as a parameter n of type int, and then with that parameter, associated with the parameter is a piece of code that's executed. Now in Java, that piece of code can return a value or not. In Lisp, that piece of code, since it's functional, must return a value. Okay? So such a piece of code is called in Java a lambda expression. That term comes from Lisp. Okay? It's an expression in the sense that that block of code itself is an object, is something that is a value that you can pass around. Okay? And that you can print, for instance, and that you can pass around as parameters of functions. Okay? But the piece of code that's executed when the parameters are assigned may or may not return a value. So once you have this concept, then a traditional functional definition can be just considered an assignment of a variable name to a lambda expression. Okay, so I can redefine the factorial on top, factorial function on top, as an assignment of the variable factorial, and I'm assigning to it a lambda expression. So this is, probably unintuitive, especially for those of you who haven't seen this in Java or previous languages. And you will understand this much better when you implement it. But based on the knowledge, based on what I've given you so far, any questions? Yeah.
So under what kind of situations do we typically use lambda expressions instead of functions, particularly in Java?
In Java, when would you use lambda expressions versus functions? Yeah. So that's a good question. And I won't quite get into this right now, but if you type it in Google, and I did, you get some answers back. I haven't seen the answers there, but I have some answers in mind. But one thing is that in Java, unlike C, you cannot go and pass procedures as parameters. You can pass objects as parameters, but you can't pass procedures as type parameters. Okay? So you can pass lambda expressions as parameters. Okay? So in this overview, I'll talk of concurrency also. And in that concurrency slide, I actually use a lambda expression in Java. Okay? I personally am not a big fan of lambda expressions because it's also in situations where the person doesn't want to go and define a function name. There's something about programmers that they don't want to give a name to a piece of code that they've defined. Okay? Because they have to think about it and say, what is this code doing? Okay? That's why people don't use named constants. They said, oh, what should I really call this? So if you're too lazy about naming a piece of code, you just define a lambda expression and say, this is and the disadvantage of not naming is that A, you can't reuse it multiple times, okay? And B, it's not as clear. Okay, so I saw lambda expressions in Java, and I said, I know what the alternatives are, and I've been living with those alternatives, so I'm fine. They're better documenting. But I did for this class because I'm putting on a different hat here. I'm putting on a hat saying that all languages have something good in there, rather than using my religious convictions here. Okay, so I'm trying to, trying to find the best in all languages. Okay? But certainly from a uniformity point of view, this is nice, conceptually nice, because I'm building up things. I'm first defining a lambda expression, and I'm defining a function definition in terms of a lambda expression, where I'm composing a set, an assignment statement, and a lambda expression to define to create function definitions. So I really like that from a simplicity point of view, conceptual simplicity point of view. Okay? Other questions? So now that I've done all this stuff, I've tried to show the Lisp semantic concepts using traditional syntax. Now I'm just telling you the syntax. Okay? And the syntax can be confusing. Syntax is important. But conceptually it's not. It's important from the point of view of using code. So let's go and see what's going on here. I have two expressions here. The first expression is very simple. It's in one line. And it's an assignment. Okay? Rather than saying pass cutoff is assigned 60, I say set q pass cutoff 60. Okay? So I'm doing an assignment, and I haven't given pass cutoff any type. That's what we expect now. And you see two boxes here. The first box is something I put in a file. Okay? Not running it in an interpretive mode. And I got nice formatting from the editor I was using. And the second box is what I typed, what happened when I asked the interpreter to load this file. Okay, you can ask the interpreter to start off by loading a file, and then you can start interacting with it afterwards. Okay, so I haven't input anything. I just said load this file, and it said, oh, I evaluated the first expression, and the answer I got was 60, because I assigned 60 to the variable, and we know that an assignment statement now, its value is the expression assigned, and the expression assigned was 60. Okay? The second thing is also an expression. It's an expression that returns an atom, or just think of that as an identifier called regular pass. Okay? You can see from here that Lisp doesn't care about case, so it took our mixed case thing and it converted it all into uppercase. Okay? Since C, people have been using lowercase if given a choice. Before C, I think it was all uppercase, so my first programming language was Fortran, which was an engineering student, and everything was capitals there too. Okay, this was built in the early days. Okay, so we say set q pass cutoff 60, and it says, oh, you just evaluated 60. There's a side effect of this. This is important. That even though the expression evaluated 60, there was a side effect, and a variable called pass cutoff got assigned 60. Okay. Now we get to the more complicated part, and if it's a regular function definition. Okay, so you might go and say function in some languages. You say defun. Okay, that's saying what comes next is the function definition. When you're doing a function definition, what things have to come next? A name. That's what the second element of the list is. So you're just giving it a list. The first element of the list happens to be the keyword defun. That says the rest of the list will be a function definition. Okay? What are the elements of it? Well, the name of the function, we'll call it regular pass. The parameters, which is a sub-list within this bigger list. And we have only one parameter called total. Okay? And then we need the body of the function. What gets evaluated to return the function value. Okay? That body happens to be a conditional expression. Okay? So that's the conditional expression itself is a sublist there. And the conditional expression, we know it's the conditional expression if the first element of the list is the keyword cont. Okay? So we get cont there. And then we come up with a bunch of pairs. Okay? And each pair happens to be left hand. One part is the Boolean expression, and the second part is any expression. It so happens that the second part also is a Boolean expression in our case, because we want to return a value of true or false. But we could be returning, a character, giving the grade, for instance. Okay. So I've got two pairs, and I'm calling them pair 1 and pair 2. Each pair is a sublist within the cond list. Okay. And the sublist has got two elements. The Boolean expression, so that happens to be, and again a sublist of that list, so it is saying greater than or equal to total pass cutoff. So if total is greater than or equal to pass cutoff, then return true. That's what we're getting from the first pair. And the second pair is saying, that's it, no more cases. If the previous cases did not succeed and there's only one such case, return nil. Okay? Questions? I've tried to comment it. Now you can see how the commenting is done here. Semicolon means start of comment. Okay. So what you will learn from all the syntax here is that the syntactic decisions are so arbitrary that people make them differently. So I always get bothered by people who care too much about syntax, and it's important, but if you think semantically, you can move from language to language much easier. Okay. Now we've returned nil. There's no false there. We return nil. Okay, and nil is like null in Java. Nil can be the value of anything. Okay, whether it's an integer or a string. If you use something as a string, it can return nil too. So it's both an integer expression, a nil, Boolean expression, and a string expression. Just like null is. Okay. So in Lisp, nil is same as false. Okay. In Java, null and false are distinct. Okay. So null does not mean false. So just a little detail. Okay. But any questions about this? Yes. You'll have to say a little louder.
Can you say false in Lisp, or do you have to say nil?
So, Lisp has evolved a lot. Who knows what all they have now? But the original Lisp did not have false. They might have added false. Okay? But nil is a valid element to return, to be used as false. They may add false as a synonym for nil in certain cases, but it's just nil. So, like I said, I went and entered the declaration in a file, and I got all these colors from the editor I used. But I could have entered all of this interactively. Okay? And it would still work, except I would never get it right interactively. I could never balance my parentheses when I was writing Lisp programs. Okay? And you'll have the same trouble too, probably. So it's nice to have an editor that's correcting you. Okay? And now that we know this concept, we can apply it again and again. So my high final pass is yet another function. I define another set of named constants for it. And we see how to do an AND here. So it's not ampersand, it's AND. Okay? Again, we use the infix notation. And we see that AND is embedded in a list with the prefix operation. So once you get used to the syntax, this has got nothing interesting. Okay. And we can do, and when I evaluate this, it says again, the first expression evaluated to 40, the second 80, and the third one just it evaluated to the atom high final pass. Okay. And I can have my list pass also, which is now we see how to do an OR. We just type OR. Okay. And honestly, when I write Java, I often go and use the word and or, because that was what I saw first in the languages I used. So it's very arbitrary what you do here, and you just have to remember. Okay. And after I did all that stuff, I entered some things interactively, and I said pass 6070, pass 6020, and I can try out my function. Okay. And all of this came for free. Nowhere did we see any I/O code. Right. and I/O automatically handled by the interpreter. And lot of, and maybe even today, a lot of CS1 courses were taught using languages like Lisp, which have all these features with an interpreter, with functional thing, and they said, let's just go and focus on the algorithms, and let's not do any I/O at all. I/O comes for free, and learn the concepts better. Okay, so you're seeing the virtues of Lisp here. Okay, questions? Okay. So let's go and show the lambda expressions now. And this is where things get confusing and more complicated, but they're really not so. So let's go. This is a very, this is a lot of nesting here. Let's go bottom up here. So we see an expression here. Okay, that's easy to understand. And which is just checking whether the total is greater than or equal to pass cutoff. Combined with that, we get a cond case pair, okay, which we know by now. Then we have a cond, so that's okay. This is all familiar. Okay, the cond happens to be the body of a function that is not named. It's an anonymous function. Okay, and that is the word, and that the word lambda says that is the kind of function. Okay, now we know why it's called a lambda expression, because the keyword lambda was used there. Okay, so we have now a lambda expression, which is just a block of code that is parameterized. Okay, think of it as a function with no name. Okay, so it's got the word lambda. You can use lambda multiple times. Okay, denoting different pieces of code. And like a function, like a named function, it takes parameters. And in this case, it takes one parameter total. So it's just like a function definition, but it's not named. Okay, and it can be passed as a parameter to another function. What do we do with an unnamed piece of code? If we are not going to pass it to a function, we apply it. Okay, so we are not only defining it, but we are also applying it. We are applying it by putting it within another list that has as its first element the lambda expression. And what is the second element of that list? What do we need for application? We need the body, we need the piece of code, and what else do we need? A piece of parameterized code, and what we need is the actual parameters. Okay, so there's arguments are used for both at the declaration time and application time. So the declaration time, we call them formal parameters or formal arguments, and calling time, we call them actual arguments or actual parameters. Okay, so that's what we have there. So we have that another list which has an extra element 49, which is the parameters applied to the expression. So this whole thing was typed as an expression to the Lisp interpreter. The Lisp interpreter said, oh, the answer is nil. Okay, I took that lambda expression, applied it to 49, and I said 49 does not pass. Okay, unintuitive, but kind of makes sense based on what I said earlier. Questions? Okay, so lambda expression is just an unnamed function. That's all it is. Okay, an unnamed thing. If you don't name it, you can't use it later. So you might as well use it immediately, and that's what we've done. Or you go and pass it to a function that uses it immediately. So it's basically, you can't just go and have a function declaration and then call it later without naming it. Okay, yeah. So that's a question somebody asked, why use lambda expressions, right? So think about it. Supposing I wanted to find out if 49 passes or not, right? I would replace each total with 49, right? This happens to be a little clearer maybe. Okay. But in general, people do it when they want to pass this piece of code to another function. And they don't want to create a function to do so. So that's typically the use for it. And more important, it's got conceptual simplicity, that we define this as an independent entity, and we can then define function assignment. Function definition is just an assignment. Okay? But that's the reason why Java has taken so long. They didn't say, oh, let's create lambda expressions, put lambda expressions into Java immediately. They said, okay, what else can we do now? Okay, let's put lambda expressions. Yeah.
So, for example, if you put 349 here, it will run the lambda commands?
No, it won't do 349s. There's another function called mapcard, which we'll look at, which will say, take this lambda function, apply it to each element of a list. That is another thing that people do, which is again saying, pass it to another function. That go and take this lambda expression and use as arguments every element of the list that I associate the lambda expression with, which is another concept we haven't looked at right now. We'll look at that later.
So what's the convention here? Is just lambda followed by a parameter?
As many parameters as they were declared. If the lambda expression had three formal parameters, we supplied 3 actual parameters, as in anything else. Okay? So I think the motivation is just a little lost here, and that's why there's some confusion. But
So the lambda function and the lambda expression and the parameter walk via parentheses.
that's just an application. That's how it's done in Lisp. That they're all in parentheses. In Java, it would be different. But the main point is that these things in themselves are something you can pass as parameters to functions, to other functions. And you can generate, in Lisp, you can generate a lambda expression dynamically. That's another thing. You can generate functions dynamically. And Lisp was meant as an AI language. It has been used as an AI language for a long time. And the whole idea was that the code learns new things by generating new code. Okay? So that was another motivation for this. Questions? Yes.
Are lambda expressions more efficient for memory and speed?
No. They're not more efficient. Lambda expressions in Lisp are interpreted. In Java, they're compiled. Okay? So, it's really, you guys know what inner classes in Java? Some of you might. So Java, Java's origins, Java is both schizophrenic. I mean, on the one hand, it's pure. It's got all these nice things like interfaces and so forth. And it's also, a lot of C programmers migrated to Java and they want to program the way they program in C. And they don't want to go and name everything. So it does all these things like inner classes and which make code less reusable. But basically, it's saying that really, if you want to live the way you're used to, you can do so without being purist. Okay, so it's just trying to save, like I said, the whole issue of trying to give a name to a function, and declaring a function is trying to avoid that work. Just as inner classes may prevent you from, don't require you to go and create a new file with a class. You can just put the class within the class you're defining to save you a few seconds of work. Okay. So this is what you can do now. I can I don't have to go and do defun function name, which is much easier to use. I can just say setq lambda, another function that I'm calling lambda quote regular class, and I assign to it the lambda expression. Okay, and it's a little confusing. Am I assigning to it the value returned by the lambda expression, or am I assigning to it the lambda expression itself? Okay, there's a bit of ambiguity. So I put a little quote before the lambda expression to say that please don't evaluate it. Okay, which means just go and assign that list to this variable. And then later, and so code and data are both lists in Java, like I just said. For AI programs, we can just create a list in memory and use it as code. Okay? So we have to go and tell the interpreter that should you evaluate this list as code or should you not evaluate it? And by default, in certain situations, it evaluates. So we put a quote saying, don't evaluate, please. And when it doesn't evaluate by default, we call the eval function, as we see here, and say, please evaluate. Okay? So, so quote list says, do not evaluate list as code. Eval list says, evaluate list as code. And so this is a function. This is a functionality you will have to provide in your interpreter. So it's good to know that these two concepts exist, and you'll be defining your own eval function that will call the Lisp eval function based on what was passed to you. Okay. In fact, that's what you will be doing in your code. You'll be given a list that Andrew's parser would have produced from the input, and you will take that list and interpret it or evaluate it based on what you find within the lists. Okay? Questions? Yeah.
Just clarify, is that will take mark that saying don't evaluate?
Sorry?
That will take mark that saying don't evaluate?
It will take more steps?
Is that will take mark that is saying don't evaluate?
Yes, 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 tick. I didn't hear the word tick there. Yes. The quote. Okay. Yes. Right. Okay, and I think there might be a quote keyword also, but this is certainly more efficient, typing-wise. Okay. Questions? Seems like a fun language. Different. Different means fun.
What is the second line of the output?
Sorry?
Second line of the output.
The second line is, the first line is saying that setQ was assigned some value, right? So the first line will always return the value that was assigned. The value that was assigned was the lambda function, right? Then I go and, in the second line, I go and say, funcall eval lambda quote regular pass 49. So I'm actually calling the function and using some awkward syntax, and that is the answer I got, and it's nil, because 49 is not pass. Okay, so in one case I'm defining the function, in the other case I'm calling the function in a very awkward way. That's why define is the more intuitive and way to do so. But this is just showing you what's going on underneath and showing you the uniformity aspect. Okay.
Oh, I'm actually asking about the first line. It's actually printing out the set Q, right?
Yeah, set Q lambda quote regular pass, and then there's the quote symbol and the lambda expression. It's a quoted lambda expression. Okay. And you know, by the way, it took me a long time to figure out how to do the application, because I didn't know when Lisp calls eval, when it doesn't call eval, and I tried about for an hour I struggled with it till I finally got it to work. Okay, and I tried to Google for somebody else who might have tried this thing out, and I just couldn't find a Google answer. Okay, but here's another way to do it. Rather than putting the quote symbol, I can put the word function there, which says that please, that's a function, don't evaluate it immediately. And then the call is a little easier. And I can say apply lambda function regular pass 49. And so, did I get an extra? Yeah, I have to put that extra piece of code there. And so this is a detail you don't need to care about. But just to let you know that there is an alternative to quotes. Okay, so let's go back to define, which is a little bit more natural, not very natural because it's all lists. And this is what I did, and we got the answer. You know, we said regular pass. We defined regular pass this way, and this was the correct thing. What if I go and assign to pass cutoff not the number 60, but because my mind wanders, a string 60? Do you expect any errors at this point? So do you expect any error when I go and say set Q pass cutoff 60 string? No, because I never typed pass cutoff. Who knows? It might be a string. No error there. Do you expect any error when I define the function regular pass? No, because it doesn't do static typing. It says we'll see what happens at runtime. Okay, As far as I'm concerned, that's a regular function. And actually, we haven't done anything wrong in that function. It's all a legal function. Okay? The trouble arises when we actually go and, we have done something wrong. We have referred to total cutoff, which is a string, but it hasn't bothered to go and check what was assigned to string. That value can change at runtime anyway. And because there's no constant. And so the greater than equal to doesn't apply to strings in Lisp. Yet it doesn't tell us there's something wrong here, and says we'll see what happens at runtime. Okay. If you run it, and then you say regular pass 60, you get a very descriptive error. Okay. You will get such errors from common Lisp because just don't make any errors, please. Anything that doesn't pass, you won't get a very helpful message. So, but we know that something went wrong. Okay. And then I can have a correct regular pass, okay, with the pass cutoff being number 60, the function being defined right, and I call it wrongly. I say regular pass with a string. You get the same error message. Okay, and it's a dynamic typing. Okay, so we are seeing now a limitation of Lisp semantically, that dynamic typing can have problems. Okay, and that's consistent with what was said earlier. Why would you ever want regular dynamic typing? And this is the problem you would get with dynamic typing. You can. Okay. So I've seen now more or less all the elements of Lisp. Okay. And the one thing we haven't seen is list processing. My problem was so simple that we didn't have to process any Lisp data. We did see that all the code was lists. Okay, so to that extent we saw lists, but not as data. Okay, and we'll do that later when I do Lisp in depth. So let's try to see where we can go from Lisp. Okay, semantically, not so much syntactically. Oh, by the way, before we do that, why are we doing this? Again, all required assignments will involve implementation of parts of Lisp interpreter, and we'll go beyond what the traditional Lisp interpreter goes. Okay, we'll have concurrency there, we'll have distribution there. It'll be fun. We'll have something called lazy evaluation there, which the regular Lisp interpreter doesn't have. So it's not just going to be a simple Lisp interpreter over the whole semester. Okay. And is Lisp interpreter educational thing to write? Firstly, if you want to figure out how to write a Lisp interpreter, just Google for that. Lots of people like writing that. Okay, so I'm not crazy here. And you're free to use these resources. Just don't look at the code while writing your own code, because that might two of you might do the same thing, and then your code will be too similar. And if we use a plagiarism detector, it will catch that. The reason I'm not too worried about that is because we will impose a structure on you. We'll give you a parser. We'll give you something that skeleton to interface with the parser. So you'll have to put your code within that framework. So no matter what you do, you will learn something. Okay, with how much you use this. And here's the interesting thing. So Andrew spent 7 hours yesterday writing his own parser. And he said, I wanted to do so because I wanted to learn how to do it myself. I'm not going to charge the course for these 7 hours, okay? Because he just has 10 hours a week, so we wouldn't have much time left for him. And you see this message here saying, hey, I really learned how to program when I wrote a Lisp interpreter. So there's at least some of you who said that, look, I want to increase my programming depth, and this will do so. Okay? So don't consult published code while coding. But the good news is that we are going to build all the other assignments on the Lisp interpreter, and you can go to Andrew for questions, of course, because he's the one who's writing it. But you also have these resources at the code level, which is great. Okay, and you learn how to read either C or Python or some other piece of code. I don't think there's a Java interpreter, and you have to write a Java one, which is good. But at least semantically you'll get to know. Okay? Okay, questions? So let's go and see whether we can improve, have a cake and eat it too. Let's say we like some things of Lisp, and the one thing that was hard to defend was dynamic typing. Okay? And you might say that dynamic typing is a consequence of the fact that we didn't type the variables. And we don't want to type variables because we've got an interpreter and we're doing this interactively, and we don't know what we are doing because we're doing AI. And so we don't want to type the variables, and yet we want static typing. Have you guys seen this before? We know in Java you got to type the variable and you get static typing. In C that's the case. Or maybe not. Any other language you guys have studied? How many of you took Chris's 110? Did you see a feature that is consistent with what we want? Did you have to type all the variables? You did? Really? He required you to do so, or you did it?
I did it when he was still teaching Java.
When he was doing Java?
Yeah.
Oh, you guys are that generation? Good. So that was that generation. No, he changed to TypeScript. Yeah.
Auto in C, right?
Sorry, auto?
Yeah.
C-
Like the auto keyword, where you can declare variables auto interpret, but you can also set it there.
And when you do it, I don't know TypeScript, so you're teaching me TypeScript here.
Like C++ is auto.
So when you do auto, what does it do?
Auto, it's as if it's a dynamic type where it inserts what type it is.
But do you get the errors at runtime, or do you get the errors at compile time?
I think you get it at runtime.
Did you do a TypeScript with him? But you know. Okay. So there is something called type inference, which also exists in Java right now for primitive variables declared within primitive local variables. So what we can do is I showed you that function, greater than equal to. Greater than equal to does not take strings as arguments. What's that greater than equal? Yeah, it doesn't take string as argument. So we can infer that what is going to be passed to greater than equal to is going to be something that is comparable. Okay? And if the range of types is very small for an operator, we can infer the types. Okay? So we don't want dynamic type checking, we want static type checking. And so Java TypeScript type inference for local variables. Okay? So there's a term called type inference. Type inference got invented early 70s or maybe even earlier, but it's a hot new feature in Java. And TypeScript is also a hot new language compared to JavaScript. So you're seeing, again, back to the future concepts here. Okay? So this is not going to be all a set of irrelevant traditional concepts. Okay? So